Okay, 7.1 is investigate properties of similar triangles. So we're going to touch on, in this section, congruent and similar figures. Okay, so congruent, what that means is it's the exact same shape and the exact same size. Okay, so all of the angles are going to be the same, but then also all the side lengths are going to be the same as this one. Okay, it doesn't mean that it's a quadrilateral, or sorry, that it's an equilateral, like triangle, for example. It's just the exact same shape, the exact same size. So this height, this width, okay? Whereas similar figures are identical shapes. So again, the angles are going to be they're going to be the same, but this time it's a different size. So the width of the base is going to be different. The height here is going to be different. Okay, so that's the difference between congruent and similar. Okay, so similar triangles have the following properties. So corresponding angles are equal. So this word is very, very important, corresponding. So I'm going to give you an example. Angle U corresponds with angle B. Angle T corresponds with angle A. And angle V corresponds with angle C. And it's important to complete these in like a certain order and make sure that we're completing them using the corresponding angles. Okay? The other thing about similar triangles is that the ratios of their corresponding sides are equal. So AB, which is right here, is going to have the same ratio. So if we do AB divided by TU, just for an example, it's going to have the same ratio as BC and UV. BC and UV, and that's going to have the same ratio as AC and TV. Okay, so I just said AC and TV. In this case, it says CA and VT. You can name them either way, but what we have to do is we have to make sure that we stay consistent. So if we go from T until V, we have to go from A until C. Okay, we have to be consistent because we're going from the double angle here to the triple angle here. Okay, so you can either say ACTV or you can go backwards both ways, CAVT. Okay, just be consistent. You'll get used to it, I promise. Okay, so proving similarity. To prove that two shapes, in our case, two triangles are similar, we must show that two pairs of angles are equal. Okay, by default, the third pair will be equal because 180 minus x minus y is going to equal the same as the 180 minus x minus y, right? So we have to show that both of these are x and both of these are y. By default, this third angle will be the same. Or we have to show that all three sides are proportional in length. Okay, so the other situation that we can have is that you can have like a 2 and a 4, and a 4 and an 8, and let's go a 10 and a 20. So if you can see, all of these angles are doubled. Or sorry, all of these side lengths are doubled. Okay, so we have to show that all of the side lengths, all three of them, are proportional. Okay, by them being all proportional, they can only have one situation for the angles in this, between the sides. And when you write a similarity statement, the order, and I was saying this before, the order of the vertices must correctly identify pairs of equal angles and pairs of corresponding sides. Okay, so again, they have to be in order and they have to match up. In example 1, all we want to do is identify a pair of similar triangles, and then we'll explain why they're similar. Okay, so if we can see in here, we have two triangles. We have this triangle right here, which is X, N, and P, and then we have the big triangle. So I'll draw this here. Okay, X, E, T. So our similar triangles are going to be named. We can start here X and X are going to be the same angle because these two triangles are actually sharing that angle. So, I don't know, let's go triangle X, and then P and T both have 90-degree angles. So let's go X, P, N. By default, N is going to be the same. Is going to be similar to triangle XTE. And you have to go in that order. XPN, XTE. Okay, and why are they similar? Okay, they're similar because their angles are the same. So let's say angle X equals angle X, and let's say angle P equals angle T. Okay, and that's it. So example 2. This is telling us that ABC, so ABC in this order, remember the order really matters, is similar to KLM. So let's go ahead and list the corresponding angles. So if the angles are denoted with like a circle or an X, okay, they're going to be the same, or a Y. So let's go angles. Angle A equals angle K. Okay, angle B equals angle L. And then angle C equals angle M. And notice how I put all of the angles on like triangle number 1 first, and then equated them to the angles on triangle number 2. Okay, so A, B, and C are on triangle 1, K, L, M are on triangle number 2. Okay, now we're going to state the ratios of the corresponding sides. So we're going to go in order. So let's go A, B, and we're going to go down like that, is going to correspond to KL. It's going to be equal to BC and LM. Okay, and we can either go up or down. It doesn't matter here. Let's go CA. Then we're just working our way around in a circle. And MK. Okay. So we put all of these in order. So that's good. If you notice, everything on the top has to do with triangle ABC. And everything on the bottom, the denominator, has to do with triangle KLM. And those are the ratios of the corresponding sides. Okay, now we're going to go one step further. We're going to actually use the sides to show that the following two triangles are similar. So this one's a little bit difficult because the way you would think that the triangles line up doesn't always happen so nicely. Okay, so because of opposite angle theorem, which means these two angles are the same, we can conclude that C and C are going to be the same. So why don't we start with C? Okay, triangle C, then let's go down to the 90-degree angle, which is D, but the 90-degree angle in the smaller triangle is B. So CDE, CBA, CBA. Okay, so triangle CDE is going to be similar to triangle CBA. And now what we can do is we can actually, if you want, write out just for practice all of the side ratios. So let's start again with C. So let's go CD is over CB equals DE. Okay, so it goes from the 90-degree angle out. So 90-degree angle out is BA. Okay, and that's going to equal, okay, from E back to C and A back to C. Okay, so these are the three ratios, but for every single one of these ratios, we can actually sub in numbers. So CD, the length of CD is 15, so we can actually just go ahead and sub in 15 there. Okay, and the length of CB is 3. The length of DE is 20, and the length of BA is 4, and the length of EC is 25, and the length of AC is 5. Okay, so we can see that 15 divided by 3 is 5, 20 divided by 4 is 5, and 25 divided by 5 is 5. Therefore, these triangles are similar because their corresponding sides have the same ratio. Okay, now, in similar triangles, the ratio of the corresponding perimeters is also equal to the ratios of the corresponding sides. So far, we've seen these corresponding sides. So we're just going to actually extend it by one characteristic. So the perimeter of triangle ABC is going to be in the same ratio, of course, as the sides, as perimeter of triangle XYZ. Okay, and then I'm actually going to come back to this. So in example 3, triangle ABC, so in this order, is similar to DEF. So let's determine the lengths of the unknown side lengths. Okay, triangle ABC, so let's go AB is over DE, BC over EF, CA over FD. Okay, and now let's sub in. 4 over 10 is equal to 5 over D is equal to B over 15. Okay, so what we can do from here actually is a lot of times I just take two of them. I take the ratio that is completely filled in, so 4 over 10, and I equate it to either like one or the other, and I just do them separately. This way, because we have one term on the left and one term on the right, we can just simply cross multiply. So I get 4D equals 10 times 5. Okay, so I get D equals 50 over 4. Okay, and I get D equals, I think it's 12.5. Yeah, 12.5 centimeters. Okay, now I'm going to do the same thing. I'm going to keep that 4 over 10, and I always keep the one that the question actually gives us. I don't, like, I wouldn't sub in this 12.5 to D and then use like the second ratio, because if we made a mistake, then we are guaranteed to make a mistake in the last ratio as well. Okay, so again, term on the left, equal sign, term on the right, cross multiply. No, I don't have to cross multiply that 10. So the 15 goes up, we get 15 times 4 divided by 10 equals B. So I get 60 over 10, and I get B equals 6. That'll be also in centimeters. So B is going to be 6 centimeters, and then D is going to be 12.5 centimeters. Okay, so now let's do one extension onto this question. Okay, so here's the next step. Show that the perimeter is in the same proportion as the side lengths. So again, I'm going to keep 4 over 10 as my start. Now, what is the perimeter of ABC? So the perimeter of ABC, triangle ABC, is 4 plus 6 plus 5. So I get 15 centimeters. Now, the perimeter of triangle DEF is going to be 10 plus 15 plus 12.5, and I get 10, 20, 35, 37.5 centimeters. So let's take these over here. So everything on the top, that 4 was from the smaller triangle, the ABC triangle. So let's go ahead and put the perimeter 15 on the top. Okay, and let's go ahead and put the 37.5 on the bottom. Okay. So if we divide 4 divided by 10, we get 0.4. And if we divide 15 divided by 37.5, we also get 0.4. So what we did right here is we showed that the perimeter are in the same ratio or proportion as the side lengths. Now let's take a look at area. Okay, so coming back to up here, in similar triangles, the ratio of the areas is equal to the square of the ratios of the corresponding sides. So a little bit different. We would take the ratio of the corresponding sides and then square it. Okay, so we have the area of triangle ABC is 8 centimeters squared. Okay, find the area of triangle DEF. So area equals question mark. Okay, so we have 4 over 10. What we want to do is square that, and then what that's going to equal is 8 divided by the area of DEF. Oops, F. Okay, so 4 divided by 10 squared. What we're going to get is I get 16 over 100 equals 8 divided by the area of triangle DEF. Let's bring that up. Okay, so if we were to cross multiply, bring this up, bring this down, what we're going to get is the area of triangle DEF equals 8 times 100 divided by 16. Okay, so 800 divided by 16, I get 50. So the area of triangle DEF equals 50 centimeters squared. Okay, last question, solve for x. Okay, so when I get a triangle like this, I actually like to draw them completely separately. So I'm going to draw this one first. We have 1.4 and we have x. And x is what we have to solve for. Then what we have is the big triangle, which is 6.3. 2 is the height, and then 6.6 is that slant. Okay, when I get a question like this and we don't have A, B, C, what I do is I actually label them. So let's go A, B, C, D, E. So we have A, B, C, and we have A, D, E. So what we're going to do is we're going to say triangle ABC, ABC, and like that middle letter right there corresponds with that the 90-degree angle. So it's going to be equivalent to, so ABC, oh, this is a D. It's going to be similar, sorry, not equivalent, to ADE. ADE. So if we're trying to solve for x, we need that 6.6 over x as a ratio. Okay? So 6.6, oh, let's do the letters first. Let's go AB over AD, because those correspond, and AC over AE. AC over AE, that's better. So the length of AB is 1.4. The length of AD is 6.3. And the length of AC is x, which is what we're trying to solve for. And the length of AC is 6.6. So let's go ahead and just cross the 6.6 up, and we're going to get 1.4 times 6.6 divided by 6.3. So 1.4 times 6.6 divided by 6.3, I get 22 over 15. So x is going to equal 22 over 15, or in other words, if you want to round it, 1.4. And that is going to be in meters. Okay, so if you actually notice, we didn't even need that 2.0 meters, but we would need that if we wanted to solve for the height of like triangle ABC, but we didn't have to. We only had to solve for x. So that's it.